Let's do some really hard SAT math questions. So, a line intersects two parallel lines, forming four acute angles and four obtuse angles. So that just means it's two parallel lines, and then the transversal cuts through these two, right? And the measure of one of these acute angles is 5x minus 420. So 5x, let's rewrite that, 5x minus 420, right? And the sum of one of these acute angles and three of these obtuse angles is this. So find the value of W. So let's say this angle is Y. Okay, this angle would be 5x minus 420, and this would also be Y. Right, that's how this would work. And we're saying 5x minus 420 plus 3y is equal to negative 10x plus W. Okay, now I can solve this, but I just need to know what the value of y actually is. So what we're going to do is we're going to just set up an expression that equates to y. So what we can do is we know that these two angles here would equal to 180 degrees because they're supplementary. So what we're going to do is 5x minus 420 plus y is equal to um sorry 180. So now add 420 on both sides and subtract that 5x. Y is equal to negative 5x plus what? 600. So now this is where Desmos comes into play. So I'm going to just put the y in to start with. Negative 5x 1 plus 600, right? And then we're just going to say 5x1 minus 420 plus, actually let's change this to another variable, z. Don't think it would matter though. 3z is negative 10x1 plus w. And we get the value of w, which is 1380. So 1380 is our answer. Let's run through another hard SAT question super quickly. So this question here is testing your knowledge on the discriminant formula. Okay, and we're being asked to find the value of k. So when we're trying to find exactly one solution, we're going to use the equation b squared minus 4ac is equal to 0. When you're asked for no solutions, it's going to be less than or equals, sorry, yeah, just less than 0. And if it's asking for infinite solutions or multiple, it's going to be greater than 0. Okay. Anyways, so I broke this part into A, B, and C, right? Always there's going to be that imaginary coefficient, right? For those x squared. It's a thing, but people just don't mention it, right? Anyways, so we're going to do b squared minus 4ac is equal to 0. So negative k squared minus 4 times 1 times k squared minus 12, and regress that to 0, and we get k is equal to 4 as our answer. Here's a really hard module 2 question. So a spherical ball is tightly packed into a cube box without a lid. Okay, so let's draw a little diagram here. So this is the cube, right? And we have no lid. And we have a spherical ball inside. Yeah, they call me Picasso. Anyways, so the radius of the ball is 1/3 of the diagonal. So 1/3 of the diagonal of the base, or any side technically of the cube, where d is diagonal of one of the cube's faces, and inches in surface area of the box is this. So what is the volume of the space not occupied by the sphere in the box to the nearest whole number? Okay, so what we're gonna do here is we are going to first find our side lengths. Okay, so if we know that we have no lid, that means we only have 5 sides. So we're going to do 5s squared is equal to 150. So 5s squared 150. You get s is equal to this, right? So now if we know that s is this, what we know is we can do a 45, 45, 90 here with trig identities. So we're just going to do s squared. It's s squared. So we get the square root of 60. So that is your diagonal, right? And now the radius of the ball is a third of that diagonal. Okay, so 1/3 of the square root of 60 is this. So now we have the sphere's radius. But first things first, now that we have our side, we're just going to do side cubed, and we get this. And now we're going to do 4/3 pi, and we can just set this equal to r, right? So r is equal to that, r cubed, and you get this. So now I could set this equal to a, and I can set this equal to b, and we're just going to do a minus b, and we're going to get 92 as our answer. Alright, let's go over this interesting question here. So, in the circle above AC, the diameter BE is perpendicular to AC and it intersects AC at point D. Given that AC is 20 and BC is 5, find AD over CD. Okay, so we're given the information that AC is 20. Ooh, AC is 20, right? And we're also told that BC is 5. Another thing we actually know is that this is a right triangle. Now, because this is a right triangle, we can actually find AB through the Pythagorean theorem. So it's just going to be 5 squared plus b squared, and then 200 squared, right? So 20 squared. B is going to be 19.36492, or square root of 375, which is just going to be easier to write here. Okay. Now that we have this information here, we need to find AD and CD accordingly. Now to find that, let's start with AD. Okay, so to find AD, we're doing the larger side over the larger hypotenuse. Okay, so x over 375 to the larger side of the overall hypotenuse. So essentially we're doing small triangle to big triangle. So now it's just going to be square root of 375 to 20. Okay, so if I were to just do the proportion here, 375, do a little regression, square root of 375 over 20, we get that x1 is 18.75. So AD is going to be 18.75. And now, if we know that AC is 20, we just have to do 20 minus x1, which is going to be 1.25. So CD is going to be 1.25. And if we divide, let's say this is equal to x2. So if we do x1 divided by x2, we get 15 as our answer. Alright, so let's do the infamous 92 over 47k squared question. Okay, so two identical rectangular prisms each have a height of 90 centimeters, right? And the base of each prism is a square. So let's just draw out these rectangular prisms first. So, not the greatest artist, but these are two, let's say, identical, right? Even though they don't look the most identical. Anyways, prisms, right? And the surface area of each prism is k centimeters squared. Now, in order to find surface area, we would essentially be adding up this areas of the squares and the rectangles, okay? And we're saying that surface area is k centimeters squared. If the prisms are glued together along a square base, the resulting prism has this surface area. So now we're trying to find the side length of each small square base. Okay, so before we take a look at the overall prism surface area, let's take a look at each prism surface area. So we're essentially going to be creating an expression here. So the height is 90 for each rectangle, right? So this is a rectangle, and we're saying the height is 90. So in this case, it could be interpreted as length or width. It doesn't really matter. But so whatever this side is, let's say this is the width and this is the length. So the length is 90 and the width is x. So the area would be 90x. But there's 4 rectangular sides on the prism. The front, the back, and the 2 sides, because the top and bottom are squares. So that would mean the total rectangular area is 360x. But the square base, right? Because we don't know what the square lengths are, it's just going to be x and x. So x squared times 2 is 2x squared. So the current prism expression is 2x squared plus 360x. This is what k equals to. So technically we could set this equal to k. Now here's where Desmos is going to come into play. So we're saying this is equal to k, right? And we're saying the resulting prism, when these two are glued together, so let me not get ahead of myself. Let me just show you guys how this would work. So this is, let me just draw a bigger one altogether. So it just has a larger height, but it's going to have the same square base, okay? Now the height is going to go from 90 to 180, okay? Now if it's 180, we're essentially saying this surface area of 92 over 47k is equivalent to 2x squared plus 720x. Now the reason we're doing this is because we're saying 92 over 47k is equivalent to whatever the actual surface area is of the larger prism, which is going to be the same for the squares, but for the rectangles, because we're gluing together two heights, 90 plus 90 is 180, and then 180 times 4 is 720. So this is essentially our expression. Now, typically, without Desmos, you'd be doing this by hand, and it would take a lot of time. But once you understand how to set up the expression, all we actually have to do is plug this into Desmos. So 92 over 47 of 2x squared plus 360x is equal to 2x squared plus 720x. Yeah, you could have set up a regression here, but I just found it easier to just type it all in. So you're going to get 8, 0 as your solution, which is actually the value of x. And we're being asked to find the side length, which is actually x. So x is equal to 8, meaning B, 8 is going to be our answer.